Hello and welcome to Empowered Learning. This particular video will be about computing permutations and combinations by hand using the factorial formulas. And so just as a reminder before we get started, we have the permutation of n things grouped r at a time, and of course n factorial divided by n minus r factorial. And of course we use this when the grouping that we're doing order matters. And here we have the combination of n things grouped r at a time. And so similar to this, but we have another r factorial in the denominator. And so we do this whenever the grouping that we're doing order does not matter, okay? So we're just going to run through some examples here on how to do it, and I'll give some suggestions on best practices when doing this as I go along. All right, so let's get started. So the first one here is going to be the permutation of 7 things grouped 3 at a time. And so here, using our formula, right here, we have 7 factorial divided by 7 minus 3 factorial, okay? And so now from here, we know that 7 minus 3 is just 4. So that would be 7 factorial divided by 4 factorial. And we learned from a previous video that one of the things that we can do with 7 factorial is break it down until we get to 4 factorial so that we can reduce that to 1. So if we do that, 7 times 6 times 5 times 4 factorial divided by 4 factorial. And here, these two 4 factorials reduce to 1. And what we have left is just 7 times 6 times 5. And of course, if we multiply all that together, we see that we'll end up with 210, okay? So let's do the next example. For this one, we have the permutation of m things grouped 8 at a time. And since we don't know how much m actually is, what we're going to do is just write the m in place where we need to, okay? So again, permutation. So we're going to do m factorial divided by m minus 8 factorial, okay? And so if you're looking at this, you may think, yeah, we can just stop right here, okay? But actually we can go a little further with this. So remember that m factorial is the same as m times m minus 1 times m minus 2 times m minus 3, so on and so forth, okay? So noting that, what we could really do here is write out n factorial until we get to m minus 8 factorial, which is right there, okay? So in doing that, we have m times m minus 1, m minus 2, and I'll keep on going until we get to m minus 8 factorial and stop there. Okay, and all that is divided by m minus 8 factorial. And so now the m minus 8 factorials reduce to 1, and so our final answer is now just m times m minus 1 times m minus 2, and we keep on going all the way till we get to m minus 7, okay? And of course, if we knew exactly what m is, we would just plug in that number for m and then calculate, okay? All right, so our next example, I'm gonna go ahead and move this down some. We have the combination of 13 things grouped 5 at a time. So now we're using this particular formula, okay? So we come here and we say this is going to be 13 factorial divided by 5 factorial, and then we have 13 minus 5 factorial. Following order of operation, we do what's in the parentheses next. So we have 13 factorial times 5 factorial times 13 minus 5 is 8 factorial. And so here we see that 13 factorial is more than 5 factorial and 8 factorial, but the bigger one here is 8. So we want to write down 13 factorial until we get to 8 factorial so that we can reduce that to 1. So have 13 times 12 times 11 times 10 times 9 times 8 factorial, all divided by 5 factorial times 8 factorial. And so our 8 factorial is reduced to 1. And so now at this point, what we could do is go ahead and write out what 5 factorial is. And so 5 factorial would be 5 times 4 times 3 times 2 times 1. Okay, so we'll go ahead and do that in the next step. Okay, and so here we see that 5 would go into 10 2 times, 4 will go into 12 3 times, and 3 would go into 9 3 times. And I think here we have 2 goes into 2 1 time. So we have all 1s here in the denominator, okay? And so now, if we keep going, we have 13 times 3 times 11 times 1 times 3. So 13 times 3 times 11 times 1 times 3, okay? So here we essentially have 39 times 33, okay? And so looking here, I see that that's going to be 1,287 for our answer, okay? Now let's move on to the combination of 8 things grouped in at a time, okay? So for here, I'll go ahead and write it out using the same formula. So we have 8 factorial over n factorial divided by 8 minus n factorial, okay? And so in seeing this, we may be tempted to say, well, yeah, we can write out 8 factorial as 8 times 7 times 6 times 5, or try to write this out to where this would match. But there's really nothing else that we can do with that. So we would leave it just as is right here, okay? All right, and so for the last one, we see that this is representing the combination of W things grouped X at a time. And of course, we don't know what either what neither W nor X is. So here we're just going to follow this same formula, but instead of N, we're going to put W, and instead of R, we're going to put X. So this would be W factorial divided by X factorial times W minus X factorial, okay? All right, and so we have plenty of examples here. I have one more example that I want to do where we're actually multiplying 3 combinations together, so you can see how when the problem gets kind of long, how we can manage it, okay? And this will be the last example. So let me go ahead and erase this right quick, and then we'll put up that example and get it going. Okay, so here what we want to do is the combination of 10 things grouped 7 at a time times the combination of 3 things grouped 1 at a time times the combination of 7 things grouped 4 at a time. And so here we're going to follow our formula here for combinations for all of these. So we'll say 10 factorial divided by 7 factorial times 10 minus 7 factorial. And then that's multiplied by 3 factorial times 1 factorial, 3 minus 1 factorial. And then we say 7 factorial divided by 4 factorial times 7 minus 4 factorial. Okay? And so Here we know that 10 minus 7 is 3. So 3 factorial, 3 factorial. 1 factorial is just 1. And of course, 3 minus 1 is 2 factorial. 7 factorial over 4 factorial times, once again, 3 factorial. And so now, if you notice, we're in a situation where we have this 3 factorial and that 3 factorial being able to reduce to 1. And we also have this 7 factorial and that 7 factorial being able to reduce to 1. And so now what we're going to do is write everything together and then see what we need to expand out at this point. So we have 10 factorial times 1 times 1. So we just have 10 factorial in the numerator. 1 times 1 times 2 factorial, and 2 factorial is just 2 times 1, so we'll just write a 2. We have 4 factorial and 3 factorial, okay? And so now we see that the biggest factorial that we have here is 4 factorial, so we want to write down 10 factorial until we get to the 4 factorial. And we'll say 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial times 2. We'll keep that 4 factorial. And now, since we're not going to go any further here, what we could do is just write out 3 factorial as 3 times 2 times 1. And so now we should have something that will either reduce to 1 or reduce somehow with something in the numerator. So here we have this 2. 2 goes into 10 5 times. We have this 3. 3 goes into 9 3 times. Of course, we have 2 that would go into 6 3 times. And of course, we have our 4 factorial there. That reduces to 1. So we have nothing but 1s in the denominator now. So we just write what we have here. 5 times 3 times 8 times 7 times 3 times 5. Okay? And so of course this is 15 times 56 times 15. And so when we multiply all that out, we end up getting 12,600. Okay? And so you see how we just did things step by step, and we managed factoring out big factorial chunks when necessary. And so this concludes the video on computing combinations and permutations using the factorial formulas.